10 boys and 10 girls take a test. We have the boys' marks here and the girls' marks here, and we're asked to compare the results. We can easily work out the mean for each. For the boys, we'll just add them up and divide by 10. The boys' mean is 52.1. The mean for the girls is also 52.1. The mean gives us the location of the center of the data. If we want to compare, we also need to know how spread out it is. One measure of this is the standard deviation. The standard deviation for the boys can be computed by doing 36 squared, add 39 squared, and so on, up to 72 squared. Divide that by 10, take away the mean squared, and square root the result. That gives us 10.0045. The equivalent calculation for the girls gives us 12.05363. We can see that the means are actually equal. The standard deviation for the girls is higher than that for the boys. So we could comment that the means are the same, but that there's greater variation in the girls' marks on the basis of the calculations that we've done so far. At this level, that might suffice. But note, statistics is never really that straightforward, and we could go further with this analysis. See how the girls have one anomalously high mark compared to the others. The boys have one high mark of 72, but it's not as far above the other values as the 84 is above these. When you have something that's extraordinarily high compared to the other values, that can sometimes invalidate the mean and standard deviation. Then you might go to other measures such as the median and the range. Let's have a look at those. The median score for the boys will just be the middle value. Note they're already in order. So that's going to be between the 51 and 51. So the median score for the boys is 51. The median score for the girls is 49.5, halfway between 49 and 50. We know that the range is just simply the largest value take away the smallest value. So for the boys, that's 72 take away 36, giving a range of 36. For the girls, 84 take away 40, giving us a range of 44. So on the basis of this calculation, the girls' scores are more spread out than the boys, as we saw with the standard deviation. This 84, though, has a big effect on the range, because the range is the biggest value take away the smallest value. Another measure that we could use is the interquartile range. The median splits the data into two sets. Halving each data set, this is the middle here, this is the middle here. The interquartile range is 60 take away 48, which is 12. For the girls, that's here and here, and the interquartile range is 10. So by this measure, the boys are more spread out than the girls. And using these measures, we have both that the boys' average is slightly higher and that they are more spread out using the interquartile range. What I'm trying to show here is that just analyzing even simple data sets like this can be quite complicated, and you might need to use several measures in order to get a picture of what's happening. There's also a lot you could write about this. For example, the influence of this 84 might lead you to conclude that these are better measures, probably excluding the range. On the other hand, most people do tend to go for these measures in most situations. Don't forget also that there's various different diagrams that you might draw as well to compare the datasets, such as dot plots and histograms.